right. So, oh, okay. Sorry, my audio wasn't working. Here we go. Um, so we're gonna go over moles today, or really counting atoms within a compound or in a certain element. So we're gonna start off slow. So we're gonna go over 2 days. Today we're gonna focus on what is a mole and very basic calculations. And tomorrow we'll get a bit more in depth. We're actually calculating moles and converting them in compounds. So today we're gonna take it nice and slow. All right. So let's get started here. All right. Ginger ale, so awesome. So, before we get onto the mole piece, let's think about units. So when you think of the term a pair, you usually think of two, like a couple, a pair of items, like a pair of sneakers, right? You have two of them. When you think of the term a dozen, you might have a dozen Kansas soda in a 12 pack, a dozen donuts, a dozen of roses. We think of the number 12. All right, notice these are units, they represent a number. And we use these units because it's universal and it's easier than saying the number sometimes. I mean, this one is a little bit bigger than this one, but sometimes it's going to be easier and more beneficial. And if you do golf, sometimes you might buy a large quantity of golf balls. Usually they come in a gross, which is 144 of something. They used to, I don't think they do anymore, but Top Golf, they used to have a little special where you go there at 11 o'clock and get a gross of golf balls to shoot on the range. There's 144 golf balls. Okay. And today we're going to introduce a new unit, which we're going to call a mole. Usually we think of moles like the thing on grandma's chin. Not a thing, not that kind of mole. Not the little rodent that lives in the middle or northwest United States that eats through people's grasses and destroys the yards. Not that creature. But a mole is representation of a large number. All right, it's going to represent. Remember, you're not writing this down right now either. You're just watching. 602, 2. Let me go and write on this big old number. There we go. It represents that much of something. So it's a lot bigger than a pair, a dozen, a gross. It's a lot. It's so much. If we thought of the actual roses that we got on Valentine's Day, if you got some, you took the actual rose itself off the stem and you threw it on the ground. And you got rid of all the buildings on Earth, took out the oceans, where it's just straight solid land, and we piled up the roses 11 feet deep around the whole world. That's how many roses there would be. Estimated about. It's a big number. All right, and we also call this right here Avogadro's number. Now I get to look at my cheat sheet over here. I can never say or spell his name right. I always mess it up. I put avocado. It's Avogadro. And his real full name is actually really big, almost bigger than the actual number. So I'm not putting the whole thing on there. It's just really big. But a guy named Sir Avogadro came up with this number, just named after him. But we're going to break it down saying it's 1 mole. A big number. Okay. Good. And we're also going to use the term, actually we're going to add at the end, even though it's just a number, we're going to use it more specifically with atoms. It means we have 602.200000000000000000000000 atoms. But we're going to use even a simplified version of that by saying 6.022 times 10 to the 23 atoms. Some scientific notation. It makes it a little bit easier. If you try putting this in Desmos, you're going to mess it up and get it wrong. So we're going to use this. Okay, that's our little cheat number. Now let's go to our notebook. Oh, no, I meant to delete that. My bad. I recorded this earlier, but realized my microphone was not on the whole time, so I'm having to redo it. Go figure. So, all right. So, label this part of the notebook moles and atoms. And I'm going to draw an elemental tile of carbon, my favorite element. All right, so I'm going to make a square here. We have 6 carbon, 12.011, and the name. And delete. Give you a chance to get that down. Do 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 do. Okay, good. All right, so the top number up here, this is like a refresher piece. Remember, it's our atomic number. It's also our protons. And if we have a neutral atom with no charge, it's our electrons also. We have our element symbol. We have our atomic mass, also known as our atomic mass unit. Remember AMUs? I don't know why I put dots there, but AMU. It's 12 AMU. Remember, that's going to come in very handy. It's a unit of measurement, like a pair, a dozen, a gross, a mole. AMU. It's another unit. It's also referred to as this is the new one, molar mass. Oh, see how that word mole came out again? Yeah, might have something to do with it. And the bottom part is, of course, the name. And I realized I wrote carbon. Yeah. No, carbon. Oops, my bad. Now I wrote it in a different color. Carbon, not carbon. All right. So let's say I have 1 mole. And I'm going to just write MOLE. Later on, we're going to shorten it up to just MOL. But 1 mole means I have 6.022 times 10 to 23 atoms. All right. If I have 1 mole, or 6.022 times 10 to 23 atoms of carbon, it means it has a mass of this much. It will weigh 12 grams on Earth. Let's see how it works. All right. So this is molar mass. It means if I have 12 grams of carbon, I have 1 mole of carbon, or have this many atoms of carbon. Now let's say I had half a mole, which means I would have half of this, or 12 grams. All right. If I had 2 moles, I have double that, and double this, which would be 24. All right. So this represents, if I have 12 grams of carbon, I have 6.022 times 10 to 23 atoms, or 1 mole. If I have 24 grams of carbon, I have 2 moles, and double this. If I had 5 grams, not 5 grams, gosh, 5.5 moles, it means I have 5.5 times the amount of those. Okay. Now let's say I have, put another element out there. I'm actually going to just pick one off of here. Okay. Cover that up. So I have nitrogen. And nitrogen. Now I have, say, 20. Oh gosh, I messed up. Let's say I have 28 grams of nitrogen. Let me move my little face out of the way there. There we go. So I have 28 grams of nitrogen is double the amount, which means I have 2 moles. All right, see, it's very simple. And double the amount of atoms. If I had, just 7 grams of nitrogen, I have half a mole. Just that simple. Okay, so that's how we're starting this video right here. That's it. And why did my line go really weird over there? So we go to the next video and start doing some basic calculations. Right? So this is the first one. There's others. I'm just having to break it up because my audio was messing up and the last one totally went mute on me. So this is part 1. Okay. Cool little intro video. Go to the next video. Next video. Oh, that was gonna be like the little solo thing. Never mind. Bye.